Nintendo Switch, let me show you what's going on. As you can see, we have a little bit of a problem, and the probability of secondary problems is high. We'll have to disassemble, remove the port, and test from there. This video is brought to you by PCB Way. We'll talk about their promotions in a minute. Board is out of the housing, and we are preparing to remove the port. While I am setting up my equipment, let me throw up my expected temperatures for this job. These temperatures are brought to you by the Amazon associate links in the description. If you head to my video description and click on one of these links and buy any of this equipment, or if you buy anything during that session, a small portion of that purchase will go to supporting the channel. And I greatly appreciate you. It won't cost you an extra dime. We'll begin by flooding the anchors with floats. We're going to mix low melt into the anchors. We'll drop the temperature of the solder, the melting temperature of the solder, drastically. And now, using the temperatures stated in the card, we will drop our port. We're going to concentrate in on the anchors first to make sure they are wetted, and then we will focus in on the pin area. The pins are on the other side of the board. And once they have wetted, the port will drop off the board. And just like so. Another nice clean pull. Because we're here already, we're going to begin our testing around the Pi 3 USB today, after we check our pads and make sure there's nothing bridged. And there is not. Let's test the Pi 3 USB. The capacitor we want to test on the Pi 3 USB is this one here, and the line we're concerned about is the line going to the chip. And we do not want a pathway to ground. Make sure we actually make a connection. Good. Now we're going to check our filters. We want continuity going from the port to the chip. We do not want continuity going side to side. And everything is looking good so far. Now we'll test the N92T36. But the first capacitor we'll test is the one connected to Pi 3 USB on the back, which we just tested. We did not have a short on it, so we should not have a short here. If we do, we've got a serious issue. And it seems to be fine. Continue testing the capacitors around the M92T36. Alright, we do have a short on this capacitor here, which is going to the chip. We do not want a short there. Continue our testing. We have another short here on this line going to the chip. So we definitely have a problem with the M92T36. This capacitor here has two lines going to the chip. In that case, only one side should be ground. And this guy here is often tied to the APU, but usually if it's short, it's not good news for your device. And it seems to be fine. Check the MOSFETs. Everything seems to be okay in this area. Check our little filter. Same rules apply with this one as the ones on the back. Now we're going to check our invincible fuse and see if it's still being invincible. It is. Awesome design. Let's check our test pads. None of these test pads should have a pathway to ground. And none do. This test pad should not have a pathway to ground. It does. We are pretty sure this is going to be tied to the M92T36 being bad. But let's continue our testing. This coil should not have a pathway to ground, but it should have continuity going through it. We're going to continue our testing around the BQ24193. Same rules apply, though it has many capacitors with two lines going to the chip. I just generally know which ones to test these days. Okay, so we have an oddball short here. I've actually never seen a short on this line, but I do believe it's going to be tied to our M92T36. If not, we'll have to figure that out. As we know we have a problem with the M92T36, let's go ahead and remove it. And then I want to test everything and make sure we've relieved our shorts, especially on that one pad where we're not used to seeing any sort of short. My advice is not to handle the chip at all until you see wetting all the way around it on every pad. Let's go ahead and test. We have a convenient ground plane right here. And our shorts are gone from here. Let us check our test pad up here, this oddball test pad right here that was shorted, and make sure our short has been relieved. And it has been relieved. Excellent. Another good thing to note, if that pad is shorted, it is also tied to the M92T36. We learned something new today. Let's re-wet our solder. What we're looking for here is that center pad to wet. Okay, it's wetted, and we want to make sure it grabs onto the chip before we let go. Remove the air, then press down. Gently, not real hard. And smash it to the board. Good, 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 and good. PCB Way is running mini promotions. Up to 60% off Flex Rigid and Flex PCB. High quality PCB assembly services starting at $30. HDI PCB from $349.68. Express solutions for all custom metal and plastic parts. Check out my link in the description and start your project today. Now to the part that everybody thinks is boring, but is one of the harder things to master on this device. I see what you are skipping. Ball solder on the tip. Just kind of want to run that ball over the pads. Not really looking to make any contact with the iron. Excellent. Same concept with the port. Just going to want to run our ball of solder on the pins. Not looking to make contact with the iron. Excellent. Green the sauce. Flow our port into place. Hold it down while it dries. Let's take a look at our visible pins. Sometimes you can neglect these a little bit when you're worried about getting that middle row. The middle row is the most important part to get down in this process. So far they look really solid and they have really nice fillets. Excellent. Excellent feed through. That's exactly what we want it to look like. Our next step will be to clean the board thoroughly and the port, and then we'll be prepared to do some power testing. I hope this video is being helpful to you on your repair journey. Just a reminder, if this is beyond something you want to try yourself, I offer these services. Just head over to micromage.repair, click on free quote, fill out the form, and I'll respond to you personally. Let's do a power test and see if this thing behaves anything close to what we would expect to be normal. First test I'm going to perform is with my PSU and my USB to 3.5mm dongle on my benchtop Siglent PSU. What we want to see here is just a quick jump in current and back down. Doesn't always want to play nice in this phase, and it doesn't seem to be playing nice at all. That's okay. Let's try with our second test. And our second test is with a modified iPhone Power Squid, which we have retrofitted with Nintendo Switch connectors, or Nintendo Switch battery connectors. And what we want to do here is with our OEM charger, we're just going to quickly activate. And what we'd like to see here is just a steady climb in amperage with no hanging. And it sure looks like it's booting. Turn on our capture, and let's see if we are docking. And there we go, we're docking. Excellent. That is good news. That is the advantage of this little dongle, is that we can test it outside of the housing and we don't have to put it back together completely to test docking, which was a real pain when we had to do that. Let's run it through a few tests. It's picking up the networks. That's good. Make sure it's still picking up Bluetooth. It is. It's charging both Joy-Cons and recognizing them both. And we already know it's docking. Excellent. If you found this video valuable, I think you'll find this one valuable too. And I'll see you there.